Hey there, my pre-calc homies. Today we are going to be looking at lesson 3. We're going to look at ellipses. Did I say 10.3? Did I say 8.3? 8.3. Alright, what is an ellipse? An ellipse is all points x, y in the plane whose distance from two fixed points in the plane have a constant sum of the fixed points are the foci of the ellipse, and the line through is the focal axis. And the focus are going to be foci will be equidistant away from the center, and the points where the ellipse intersects are the vertices of the ellipse. Okay. Let's get some definitions in first. Okay. Actually, nope. I'm going to do this as a warm-up once more. No, I can't. I'm just going to do it. All right. The center is the center. So this is my center. We all agree on that? Now the foci are two parts that are equidistant away from the center on the major axis. It's like I could say here and here might be my focus. Now be careful, because down here they're going to be up and down, right? Because that's my major axis. My major axis is the part that's the widest. The points where they intercept are my vertex. Okay? So this would be a vertice. I should change color. All of these brown ones are vertices. This is going to be a key part. We're going to need to find the focus, the center, and the vertices. Okay? Vertices. And down here you're going to have one here, and here, and here, and here, right? All these are also vertices. So you have 4 on each. Okay? Now we do have chords on here, just like we had for a circle. Same as a circle. I'm not going to draw it. Now one thing that makes this different is we have a major and a minor axis. That was loud. So if I do some dotted lines here, I have one here, one here. This would be my major axis. And this one up and down would be my minor, because it's smaller. Okay? Major axis, minor axis. Now we got some other special things. We're going to call the length on the major axis A, because all the way across is 2A. The length on this minor axis we're going to call B. A will always be your major axis, and B will always be your minor axis. Even if we scroll down here, with this picture, we're going to have our major and our minor. Okay, so for this one, this would be my minor. And this one would be my major, right? Because it's my bigger one. Bigger one's always the major. So for this one, okay, this would be my B. And this would be my A. Okay? Now we got one more thing to talk about that we're going to label C. And this distance to my focus is going to be C. This distance to my focus is going to be C. Okay? Yeah, that's what we got. We're going to have 2 foci, 4 vertices, a major axis, a minor axis, A, B, and C. Hoo-da lolly, golly, what a day. Okay. You'll get more of this when we actually go through and graph them. So, the reason why we have A, B, and C, we're going to use the Pythagorean theorem to find our missing parts. I'm not going to get too much into the proof. I want to, I won't, for your own benefit. Biggest things to keep in mind when looking at this picture, there's actually 2 things I want to get. The whole thing here. The biggest things with this picture up here to keep in mind is, if I get there, right here. Because of the Pythagorean theorem, your b squared equals a squared minus c squared. And remember, a squared, think about that as your major semi-axis, because your whole axis is 2, and this is your foci distance, right? Focus distance. And then this is your minor. Okay? And also because that my focus, c, is equal to my major minus my minor squared. Because a squared is, a is always your major. It's always your biggest part. Okay? So for example, if your major axis is horizontal, so if it looks like this, the left side, then a is under x, okay, because a is your bigger number. Now, if a is your bigger number is under y, your major axis is vertical. I know this is a lot to keep straight, but you can do it. All right, let's do an example. It'll make more sense if we do some more examples. Okay. Let's graph a basic ellipse. All right. So we have x squared over 25 plus y squared over 9 equals 1. So right away, I'm going to find my a, b, and c. So a is going to be my biggest number squared. So a squared is 25. So that gives me a is 5. So that's 5. B is always my smaller number. B is not always under y. It can be under x. So b squared is 9. So b is 3. Now how do I find c? Well, I look up above. C squared equals my bigger number minus my smaller number squared, right? So c squared equals my a minus my a squared minus my b squared. So c squared equals 16. So c is 4. Okay. So c is 4. Now, because my biggest number was under my x, my major axis will be horizontal, the x-axis. Okay. Now, my center, we haven't done any shifts yet. The shifts are going to be hk, just like we do with circles, x minus h, y minus k. But this one, my center will be 0, 0. So that will be my center. Now, my major vertices are all 5 away on the x-axis because it's horizontal. So they're 5 away from my center. So I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now those points are 5, 0. So I'm adding these to my x-coordinate because it's under x. And negative 5, 0. And I'm subtracting it from my x-coordinate because it's under x. That's how I remember it. Now my minor vertices are b away. So I add 3 to my y, subtract 3 from my y. Go up 3 and down 3. So those points are 0, 3 and 0, negative 3. Now to find my focus is c away from the center on my major axis. So c was 4. So I'm going to go 4 on each direction. I'm going to add 4 to my x-coordinate for both. So I get the point negative 4, 0. And I get the point 4, 0. Again, this looks really the more you do this, it's the same thing every time. It's not that bad. So now I have my vertices, my foci, and I draw it in. And it looks like a football. Okay? Alright, that's where I want to leave it today. I just wanted to intro it. I'll do a few more tomorrow and get you started. Hope you enjoyed.